the moon is not a hospitable place for human beings. So the challenges that we all have to face to settle a colony there are very great. Despite its proximity, the moon has characteristics that make it a very different place from our planet. First of all, its diurnal period is very different from Earth's.
It depends where you are on the moon, the length of day. If you go to the poles, your day can last most of the year because you're in almost permanent illumination. If you go down to the equator, then you get about 2 weeks. So you know that you've got about 2 weeks of day and then you've got about 2 weeks of night. So it would be a completely different way of living. And you'd probably have to artificially create day and night.
Its gravity is also different from Earth's. While we have a gravity of 1 g here, on the moon, it's just 1/6, 6 times less than on Earth. As of today, we don't yet know exactly how this lower gravity could affect human health in the long term. We know that exposure to weightlessness over month-long periods cause deterioration of physiological systems, such as loss of bone and muscle mass and a depressed immune system. Similar effects could occur in a low-gravity environment as the moon's, although it is still unknown.
The moon has 16.6% the gravity of Earth. Mars has roughly 30% the gravity of Earth, 33% the gravity of Earth. We do not know what the human body does with this amount of gravity. We literally have no idea. Is it more like having 1 g, full gravity, or is it more like having null gravity? We actually don't know. We presume it's a spectrum, that the moon is more like having no gravity than Mars is. Mars is more like having full gravity than the moon is. Those are just sets of assumptions we've made, but we actually have no idea.
Temperatures on the moon, as well, are also completely different from the Earth's, which would condition certain aspects in the functioning of the colony.
You get a temperature swing of several hundred degrees between lunar night and lunar day. The temperature difference is so great, it actually triggers seismic activity.
The frequency and duration of seismic activity on the moon is such that it becomes a serious hazard to the integrity of a permanent base on the moon.
There are a group of moonquakes called shallow moonquakes, and some of these reach magnitude 5 or above. And in terms of Earth, that's reasonable. But when the moon has a seismic event, it keeps on going. It doesn't just last 30 seconds to a minute. The maximum ground motion lasts 10 minutes.
Another of the characteristics that might affect a lunar base is that, unlike the Earth, the moon has no atmosphere to protect us from radiation and other dangers.
Not having an atmosphere on the moon affects several things. First, again, is safety from micrometeorite impact. It comes in faster than a bullet, and you don't want to be in the way of that.
It also leaves the lunar surface exposed to half as much radiation as in interplanetary space, raising the issues of the health threat from cosmic rays and the risk of proton exposure from the solar wind. Apart from that, it's known that the presence of volatile elements on the moon, such as nitrogen and hydrogen, is extremely low. If we are not able to recover these volatile elements, they will need to be imported and recycled for life support in industrial processes. Unfortunately, this fact would serve to limit the growth of the future colony, as it would be dependent on imports. Despite all this, the proximity of the moon offers several advantages that make it the most obvious natural expansion after Earth. The duration of the journey to the moon is short. In fact, the transit time of the Apollo missions was just 3 days. In the near future, the technology will allow us to reduce it greatly. This short transit time would also be useful in case of emergencies. send emergency supplies to the moon or to evacuate a human crew back to Earth.